what society as a whole is learning is how to use data, right? And we're all participants and victims of that every day. Data is pervasive. The other thing I'd say is data is not going away. Automation, control, sensors, the Internet of Things, right? What do those devices produce? They produce vast amounts of data. So if we have data and an overwhelming amount of it, it all boils down to data management tools. The buzzword we can use to kind of encapsulate all of that is analytics. This is an imperative for virtually all types of businesses. They have to figure out how to manage their data, whatever it happens to be. One thing I say is we're not going to sit down in 5 years over a beer and go, remember when data was the big thing? Oh, that fad's over with. I'm pretty safe on saying that's not going to happen.
Yeah, probably not.
Welcome to Future Perfect Tech, a webinar and podcast series by Harbor Research. Each month, we'll be having discussions with the leading experts in smart systems and the Internet of Things on innovations in markets, technologies, and ecosystems that are working together to build a better future.
I do believe in the strange way I'm optimistic because I'm sure we're going to have the models
John Petsey is a partner and co-founder at Sky Foundry, the developers of SkySpark. John has over 30 years of experience in automation, energy management, and M2M IoT.
All right. Thanks, Owen. Appreciate being here. I think one of the things that's interesting is to watch the evolution of the controls and automation industry as microprocessor technology came in and led us through the last 35 plus years. And, now we're in the data age. So we're excited to have the opportunity to talk with you about data analytics, and of course about this topic that we'll touch on today, the need for distributed architecture and edge to cloud data architectures.
And of course, we're joined also by Glenn Allmendinger, president and founder of Harbor Research. Thanks for joining, Glenn.
Well, it's good to be here. And John, thank you for joining us. We've had a long road. We've been on together for many years around these topics, but they're finally getting to the interesting part, the data and how distributed systems and compute and all these technologies are beginning to conspire to really yield some significant value.
So, John, in previous conversations, we've identified the need for better data management tools. How do you look upon the need for better data management tools from your perspective?
Yeah, so I think we can look wider on that. What I see is all of society is learning how to use data.
When people get into the subject of data, they don't really understand that there's so many different types of data. There's structured data. There's unstructured data, like a web page is unstructured data. Structured data is what you find in your payroll or Oracle database. But there's semi-structured data, and there's simple semi-structured data. There's complex semi-structured data, and there's time series and temporality to data. And so I think one of the dimensions that all of this tends to drive is the fact that eventually you kind of have to, like a club or a group or, social group or otherwise, you kind of eventually have to get conditions that people agree on as it relates to how they deal with these different data types and organize them to make them really usable and available to analytics, right?
Yeah. And I think that brings up a really great point. Through our 10 years, we've spent a huge portion of our time just educating people about data. Because, if you have a automation system and you can pull it up on the screen and you look at it and you see, the valves opening and the pump is spinning, whatever, you don't necessarily think about what it took to get there.
Right.
And within a proprietary vertical system, somebody decided about the structure of that data, right? And that delivered the screen to you. But now if we're going to work with data from diverse devices, bring it together so we can find patterns and correlations across it, all of a sudden, the structure format of that data is actually the big problem, the big challenge, right? And oftentimes people are shocked and surprised at the complexity that can bring with it, right? As you say, completely unstructured data doesn't mean unvaluable data, right? And highly structured data doesn't mean it's the most valuable data. And the people who are integrating all this data for analytics, they have to deal with it. And then there's standards to help with that, et cetera. But yeah, that's a huge part of it. And then it leads to, the topic we'll get to is, where are we going to process this data? What are we going to do with it? Right.
Right. Which is, I think the trigger here is the temporality of it. Time series data. In other words, whatever you listen to these outrageous statistics that get tossed around, like 80% 8% or 98% of all data is useless after a few seconds if I don't grab it and do something with it, because so much of the world exists in a deterministic real-time context. But this does get us to edge, or what maybe some more formal people might say is distributed computing architectures. In order to be able to process it, I need to process it close to where the data was created. And so, like a two-sided coin analogy, I need data management tools in order to organize all that data, but I need to actually be able to process it in a distributed context, near where the action's occurring, where the data is being created, and the decisions need to be made in real time. Fair?
Yeah. And we actually lead with the term distributed computing, because what we found is if you say edge or cloud, human beings have a tendency to follow into it's one or the other, right? The battle. No. This is a distributed computing problem, just like controls are. One of the things sometimes I'm surprised that a lot of the people who are coming into the Internet of Things from more data background haven't been through the learning we've been through about distributed controls, right? There was a time, right? And I'm sure you remember, probably just you and I, Glenn, where big bundles of wire came back to a mini computer because everything was centralized.
Right.
And control was done that way. And then the next level was, smaller bundles of networks will come back, but still all the brains are in one central, computer. And that quickly had to move on to true distributed processing, distributed control, et cetera. Well, data is no different. What I find is the first generation of talk and solutions for data analytics, they gravitated toward a cloud viewpoint, which is fine. The cloud's really valuable. But the edge is really valuable too. And what we see is, people are coming around to understanding that this is a distributed computing problem, and it has to be solved with distributed computing technology. And it's not an either or, right? And the battle of either or isn't going to help anybody.
Well, it's like snipping the umbilical to client server.
Maybe we could just take a slight detour, and just for those who may not know exactly what a distributed application entails or how one goes about creating that, is that something that's worth exploring?
Yeah, absolutely. We've been talking about a little bit about the why, but let's talk about the what. What do we mean? Sure. Yeah, I'll take a quick shot at that. I guess at the first point, distributed architecture means that we're going to deploy an application on multiple computing nodes, and it also implies they have to connect together so that they can share data, communicate with each other, et cetera. Right. So that's what we mean by distributed computing environment. And so there's some type of networking between those nodes. There's an application running on those nodes, and they can coordinate their operation together. I don't know, Glenn, what do you think?
No, that works. I think the big divide between yesterday and tomorrow is this notion that even in an old, I got a bunch of mini computers sitting in a General Motors plant someplace, and they're all connected back to some central function, that I don't need to go back to that central function in order to make a decision. So if the decision is whatever the local compute and the application that's getting processed, that thing can essentially exist in a more or less fully autonomous manner as it functions at that local point.
Mm-hmm. You bring out a really good point about the whole concept of analytics and what you do with analytics. We're often, asked the question, okay, what algorithms do you have? We believe it has to be programmable. What do you want to do? In stage one, you may just want to collect data from those distributed energy resources or loads, so you understand what's going on. And then you develop thought processes or algorithms around what you want to potentially do with them. And then the next level might be, okay, now I'm going to figure out how I can work with the trading desk for the financial decision of when do I want to do something with that.
Right.
That's a layer of hierarchy and intelligence that, it might come out of the box on the initial RFP, or more likely it's going to develop over time as people learn the data, the characteristics, the performance, the trends, and the opportunities. If you don't know how your grid or your building is performing, you don't know what potential opportunities you might have to do something valuable. So that's, we're always saying analytics is a journey. You can start out with a list of top 10 things you're going to do. Quickly, it's going to change. Right?
I don't think this is a normal mindset for people to default to. So John, I completely concur that discovery is everything, because it's discovery in context of use, right? But we had a client in the company I was on the board of directors with. They were putting ARM processors into the piece of plastic around the outlet of a plug, right? And my example was whether you plugged a washing machine into that thing or you plugged a copier into that thing, you could do asynchronous data processing at the plug point. Yeah. It can tell you whether I did colors or whites in my laundry cycle, or whether I did a color copy or a black and white copy on my copier. And if you put that in just an energy usage context, I can turn the energy on and off, and I could do things like time of day pricing, and I can, these are primary, what I have always called primary control points, right? The ancillary control point is that, and actually we met this interesting appliance manufacturer in Italy who pointed out that in white goods buying behavior, more than 50% of the next purchase for a refrigerator or washing machine or dryer is a different brand. And nobody in the industry has ever really been able to figure out why. So there's like this desperate search for ancillary data value, which is just what are people doing with these things? And what defines, what of those characteristics and attributes people are using them for? Can they derive, somewhat better understanding of features and functions and capabilities that might attract a resale, right? And of course, then you have multiple layers of tertiary value. The utility gets part of that value because they know when you're turning things on and off. That could be shared with a system that is doing distributed energy or demand management kinds of functions, and on it goes. But all of that is really built out of two fundamental pillars: distributed compute and networking, and distributed data management. Essentially, the IT world has always suffered under von Neumann architecture. I batch all my data together, and if I look at that like a giant soup stock pot, I throw everything in the pot from the last 3 weeks and hope that I can predict the next few weeks based on what I can intuit out of that. But you can't process enough in that batched architecture to ever honestly do the kinds of things that you can do with distributed systems and local data processing.
Yeah, you can't do those things. Yeah, I think that's the key in helping people understand the things you just can't do for a variety of reasons, right? One of the reasons is latency. That's probably the easiest one to come out. We can't wait for the data to get to the cloud to make a decision, and the way I try to help people understand is think of the self-driving car, right? We can't wait to send data to the cloud to make the decision to put the brakes on.
Right. You hit the person crossing the street. Yes.
Edge process.
Right.
Everybody gets it. But now let's continue with the cars, right? There is data we want to work with at the cloud, right? We're all using map applications on our phone. How does that happen, right? All of this anonymized cell phone data goes up to the cloud, and they can determine, hey, all the cars are slowing down here. I bet there's a traffic jam, right? And that can't happen at the edge, right? There's a good example of value we want to get out of vehicles or other machines where there's a role for the cloud and a role for the edge. So the architecture has to support it.
I've always described it at the edge or at the distributed point of processing. You are doing real-time deterministic things more often than not. And it's all based on data as it's occurring and in therefore, quote, real time. There are ways to think about the models that drive all this. So if I have a model for that kind of processing at the edge, I might have an intermediary model where I'm comparing what I'm collecting to some existing model that's conditional. Like the easiest example I know of is all of this movement towards road weather, where I can put sensors on trucks and other vehicles, and I can get real-time road conditional data, but I can compare it to today's forecast. And that's what I call conditional data. And then I can also have a 3-year, 30-year, or 300-year model of weather, which sits in the cloud, and it can go up and do things to compare and contrast and set yet another decision context to that can supplement what's going on in real time.
Yeah.
But you get a lot more sophisticated at the ways you can meld these different worlds and your ability to understand things from, legacy analytics and other capabilities that you can combine and recombine in interesting ways to fit whatever task you're trying to drive.
Right. As long as you think about it as a distributed computing problem, right? That's exactly it. But, we talk about latency, but there's a couple of other really important reasons we need distributed computing and be able to process data and analytics at the edge. So the next one that we see is what I call constrained networks, right?
Sure.
Which means you couldn't possibly send all the data up, no matter whether latency was or was not a problem. And when you say that, the first thing people think of, okay, slow network, okay, I get it. But there's other type of constrained networks, which I give an example of an application we've been involved in. Sometimes networks are constrained by something other than performance. So we have a customer that does demand response, and they have thousands of nodes out in buildings that are part of a grid system, and they want to make intelligent decisions for load management. Okay. All of those devices are connected over cellular modems. And a project like that, you can see where this is going. You know who's going to make the most money?
Yeah.
the mobile network supplier.
Yeah, the carrier.
If you need to flow all that data because they're billing on the volume of data. Well, what about if you can collect the data at the edge, run the algorithms at the edge to make decisions, and the only thing that goes up over the cellular network is a decision or a refined piece of information that then the cloud-based platform can make its own decisions and send out dispatches to go into load management 1 or, load management 2 or recipe 1 or recipe 2. That application, we saw, data traffic cut by more than 100 to 1.
Right.
If you even could flow all that data up, the cost would be enormous. And then the other side is reliability, right? And, the analogy I make for that, which I guess over the last year, we've all been on far more video conferences. Has anybody had a video conference interrupted by a technical problem or a loss of network? Reliability matters, right? And it isn't just reliability of, can the edge connect to the cloud? There's multiple layers of reliability. One of them is, if I'm collecting really valuable data, I need to be able to collect it locally, right? In case I lose my connection, I have a buffer. Okay, right. That's one thing. And that's pretty well understood. Well, let's go to the next step. There are certain edge processes, like we've talked about, they have to continue operating even when I can't connect to the cloud, like the brakes or the safety on the stamping machine, right? So that has to run locally, right? And the next one I'd use an example. Can you imagine being an operator of some type of machine and you're in the building, you're standing beside it, and it's making loud groaning noises that makes you worry that it's going to explode. And you can't look at the data because the UI is served from the cloud and the network is down and you're standing beside this thing and you can't look at the information from it. No, you can't accept that. So you want the local edge application to also be able to serve at least a basic UI of what's going on. And there we go. We've just described edge, cloud, and, some of the key reasons why we need edge computing for data and analytics. Hey, I want to touch on another reason that we're seeing the need for distributed computing, and that's the whole security component, right?
Yep.
We encounter numerous customers that can't send their data to a cloud, right? And when Brian and I started the company, I worked on the business plan. Brian was working on the technology back in 2009. And our original business plan was around a cloud-based application. And after I went out in industry, talked to a lot of people, I was able to come back to Brian, my partner, Brian Frank, and say, hey, this cloud stuff's really cool. But if we do it, we will guarantee to lose 50% of our possible customers. Because it doesn't matter how good it is, that they've heard the sales pitches. They won't send their data external to a cloud.
Right.
It's their decision, right? And people ask me, is that still the case today? And I said, yeah, it's still 50%, but it's a different 50%. People who wouldn't send it to the cloud will, and people who would will not.
Yeah.
Security, right? Whether it's regulatory, the data has to stay on premise, right? We have a large customer manages commercial facilities, buildings, and they actually have a NOC and they run, analytics there, but they have customers in other countries so that they have to have that running in another country. The data stays there. The network operations center staff still reaches that with their browser and they dispatch and report and do all of their functions, but the data never leaves the local jurisdiction or even the local premise, right? And so the whole security in a variety of different ways is a need for distributed computing as well.
Well, I think this also just fits it. I mean, if I'm trying to secure devices at the same time I'm trying to secure networks at the same time that I'm trying to secure data and applications. Mm-hmm. It just says the configurations in these distributed architectures can be many, but serving very unique attributes and use cases and needs, be that on-prem data or any number of other kinds of functions.
Well, that brings up a key point. We have this distributed architecture, edge to cloud technology. The edge, we're talking devices as small as a Raspberry Pi Zero running the full stack, and then industrial computers on site, and then servers on site, and all the way up to the cloud. And when we talk to people, one of the things we've realized we have to be really careful is, Glenn, we're not telling you must distribute your application to this level or whatever. We're saying you can assess your needs and determine what level of distribution you need. The choice, the flexibility to design is really the point here, not you must fully distribute it. If your application will live with, non-distributed or semi-distributed computing, fine. There's no problem with that. But you need to look at what you're trying to accomplish, right? And where the data, the compute, and the user interface needs to be.
Some other interesting use cases. I think some of the challenges that we see amongst our audience and client base are, really trying to get their heads around what they can do with this technology. And it's very difficult if you're sitting in the position having to decide whether to implement it. You may not have that ultimate use case that's going to deliver your return right away. And so their imaginations may need a little bit of prime pumping in order to be able to get that thought process going. What are some things that could help them get over that initial hindrance?
The challenge of helping people understand how data can help them. That's one of the things we spend a significant portion of our time on, right? Because again, data and analytics and this is new to the world, to society, right? We're only, what are we in? Maybe a decade?
Yeah, kind of.
But maybe let's say, we're only 5 or 6 years into, but I'll give you a good example because it'll key off of, something Glenn said earlier about bringing totally different data sets together. All right. So everybody can get their head around the idea. I have a facility and it has an electric meter and I get KW and KWH from it. And I can look at the patterns and I can see that. I can see what my peaks are. Now let's take a totally static piece of information that is actually critical to that, which is the electric rate that you're under, the tariff rate you're under with your utility company. And we say, do you realize that the high possibility that, Glenn, you might be able to save money without reducing your energy consumption at all? Because if you understand what your energy use pattern is, you may be on the wrong rate. And this might be a significant savings, right? And in order to do that, you've got to combine these two data sources that have never really lived together, right? The tariff rate you signed up for against your actual detailed interval meter measured usage, right? Which, unless you are, there are energy managers who study it, but most companies I talk about, they go, well, I don't know, it's something like this, right? So there's an example of bringing those two types together and quickly and easily generating financial value. It's typically relatively easy to get that data from your utility company, even if it's not live in real time. You don't need that for this analysis. And it's easy to get your tariff rate. It may be harder to interpret the document, but it's easy to get your tariff rate. And now all of a sudden, in a fast to value project with limited engineering effort, you can produce value out of data.
I think it's a natural state that people don't imagine all this. So maybe we should talk about some apps and use cases that you've been dealing with at Sky Foundry, John.
Yeah, sure. So that one was fascinating with the utility company for the demand response. There were so many nodes, and once we had introduced them what could be done at the edge, their eyes lit up because they were getting pummeled by these data chargers. Right. That was a real issue for them. But, other applications we have, I'll go to one thing about, I know machine learning will come up, right? I think here's another place where there's been this thought process that machine learning can only happen with huge volumes of data. That's not true, right? No, of course. There's machine learning you want to do on huge volumes of data, but there's advanced math, algorithms, machine learning you can do on smaller amounts of data to optimize control loops, right? to understand perturbations, to understand anomalies. That type of stuff can happen right out at the edge. So we have, we have partners who are specialists in what you would consider industrial processes. And our businesses, we're very much focused on the built environment, but that includes batch processes, right? So we have people who are specialists in beer production, right? And their application is to continuously drive energy out of the beer production process, with a huge amount of energy goes into every beer you drink. And they do that by looking at the performance of all of these many steps in that process, and heat exchangers and valves and all of these types of things, and identifying, faults. Okay, great, it's broke, but more anomalies and trends. You can tell when, efficiency of heat exchangers or other pieces of equipment is starting to drop off. And now you can start making decisions of, let's run a maintenance on that piece of equipment, because I can prove that the maintenance will pay for itself in 12 hours, 24 hours, or whatever, as opposed to, gut feel, which was okay. But as we know, more and more of the senior operators are leaving, right? Those are, that's another example we've seen out there. And then, the biggest thing we see is, actually, you call it fault detection, but I hesitate to use that word because that often means it's outright broken and everybody should know. Well, that's not what fault detection, and that's a type of fault, but there's lots of other faults that systems may be resilient enough to keep working through, but they're not running right. They're not running efficiently. The difference between outright faults and what you can get with analytics. I'll give you a healthcare example. Different doctors want their operating rooms at different temperatures and, conditions when they operate, right? You want the doctor to be happy. So example from a hospital, doctor, they want the highest airflow, cold temperatures, whatever, right? And so, the operators set it up for that. Well, it's a variable air volume system. So you've got a variable frequency drive controlling the fan, right? And these things cost a lot of money, right? But do you know what the weak link in the chain is for that? It's a $25 piece of plastic called the pitot tube that senses the airflow. Okay.
Right.
So the pitot tube failed and said, we need full airflow, right? It wasn't recognized. It just said more, it's low. So the VFDs set it 100% all the time. Now, the operator's busy, the facility manager, and he looks at the screen, and what does he see? He says, it's requesting 100%. The VFD's putting out 100%. Everything's okay. It just runs that way 24 hours a day for a year, even when the operating room's not being used, right? Did the fault happen that would prevent proper operation of the room? No. So it goes completely unnoticed. But this gets to optimization. The optimization opportunity was completely lost, right? Because of these loosely coupled systems and no overall view of the data and analytics performed on it. But it was an outright fault that would, cause the phones to light up and people be screaming, right? And so many facilities have historically been organized around, when it fails, it gets attention, when it's a noticeable failure. And that also brings up another point about, running analytics more at the edge, which is to be able, I think you mentioned this, to be able to compare current performance to model data that you may not be able to contain in the local device, right? Due to the size of the data set, et cetera, So there's examples there where we're seeing people compare their actual energy performance against the design model that came out of using energy, modeling tools, forecasting tools.
Well, I think, just in the context of your earlier comments about machine learning, I mean, a lot of it says I get to be able to model and maybe even simulate before I model in ways that allow me to design algorithms that can be deployed to much less compute-intensive devices. So I am processing quite a bit less because I've actually got something out there looking for the anomaly or combinations of events that can feed my understanding of, whatever, predictive equipment of failure or whatever.
I like that example, right? Maybe we would use some really advanced large data set machine learning, but we identify the algorithms we want to run. Well, those algorithms can run effectively at the edge once we know. And we often see that people get tied up with that. They think you can't run advanced algorithms at the edge. You might not develop it down there, but you can certainly run it down there. The other thing we find is that machine learning and AI techniques are good, but they are only one. There's lots of other advanced math techniques that run very effectively at the edge and are part of doing analytics, pattern recognition, frequency domain analysis, advanced math calculus, matrix math, right? All of those types of things can run very effectively at the edge.
I mean, another simple example, Owen, would be, patient identity in a hospital or health delivery context. Patient X was scheduled to go get surgery, and patient Y shows up to the surgery ward. And what happened to the missing surgical instrument at the end of the? And so, to me, these are all what I've always called simple apps. All I'm really doing is putting together, I'm triangulating or putting 2 or 3 or 4 pieces of data together to confirm or deny some state or some capability or some charge or otherwise, which ends up making up like 90% of the world of analytics, I think.
I completely agree. You just described a simple app if you have the data.
Right.
In a normalized format, so you can say, oh, I have an idea. Let's run that query analysis rule algorithm. But can you imagine saying, I want to implement a system just to do that one thing? You'd never get there.
Right. And the minute you introduce 2 manufacturers of 2 different devices producing 2 bits of that data, you right away you have a standard and an interoperability issue. Can they agree on the terms and conditions by which I can fuse this data and make a decision to do X, Y, or Z?
This gets to some of the challenge, back to Owen's question, of helping owners understand, because if you present 1 or 2 or 3 potential application examples, are those on their own, let's say they agree with them, are those on their own enough to pay for the systems integration work to get the data platform there, right? People have to understand it's going to grow over time. So I'll give you another example of what about an organization that owns, hundreds of buildings, and they've been built over the last 30 years, and they run analysis on age of building, and find out that design we were building in the 80s was actually more efficient than the one we just built, right? Were they ever able to know? Or how about we always bid out what equipment we're going to put on for, energy, HVAC, whatever. Have we ever tracked number of service calls per vendor over time, over the years, right? Could you have sold the system just on that example, like Glenn's other examples? Maybe, maybe not, depending on how high the pain point was for it. But this is what people need to understand. Data has value, and that value will continue to evolve as you get greater understanding,
Right. So if you think of simple data, I take an alert and alarm and I compare it to something like what I'm being charged or the state of the machine or something simple like that. If you go to a compound example, this is where you start wanting to combine more things in more unique ways within more explicit time intervals, right? So that's like the car or truck running over the person at the intersection, right? And, if you go up to complex, it's kind of the end state of that, like all these dreams about being able to essentially modernize how we optimize the flow of traffic through a city, would be a good example of that. Or emergency response services. I've got the ambulance dispatched to the accident, and I'm now hooking the patient up to various data collection. And I want to make sure that the hospital knows any number of things that they're going to sort and analyze at their end as well in a compound kind of application about which specialists and which place and what happens. Meanwhile, you might have an application running in the interim of that's just trying to tell the ambulance driver what's the shortest distance between the accident site and the hospital that he's delivering the outpatient to. And so if you translate these things, it doesn't really matter whether it's in a city or it's in a factory or it's in a building. All these systems, once you step into this world of compound data relationships, are all a bunch of interrelating data that requires interoperability, therefore these data management tools, but also requires all that local processing for this to all occur.
Yeah, right. All the things that happen in the ambulance, right? Yeah.
Right. So you're aggregating. In many ways, you're aggregating things to communicate based on the analytics that are occurring at the event. So whether it's routing a vehicle or, detecting or predicting a machine breaking in a factory, or a supply chain being able to function, effectively across, all the different material feeders and all the things going on within various factories and so forth. These are all predicated on the ability to process locally in a highly distributed way, interrelate data from all of those processing points in ways that allow for aggregate decision making, and eventually, to what we were describing earlier, the ability to essentially relate this to models that I can look at much longer time frames and over much longer operating histories, and understand how to further optimize and manage any one of these kinds of complex systems.
Yeah. I really like your term compound, right? Because, let's go to the stamping machine, right? The local process throws a safety so the person doesn't get injured. But a higher level process might watch all the machines and see how many times each one went into safety, and why does that machine keep doing it? Do we have a problem with the machine or an untrained operator, right? That isn't that complex, but it's an example of compound. So I like that as a term, because everybody wants to jump to this really complex. Wait a minute. These compound examples are hugely valuable, and they're not that sophisticated to implement, actually, right?
Right.
But again, they all go back. You got to have this interoperable or normalized data platform so you can come up with these insights and easily implement that. I want to see the failures per machine or per operator or whatever, right? In addition, everything we did at the edge to, maintain the safety of the operator or show that ambulance driver how to get to the hospital as quick as possible.
Right. Where I think all this is heading is we still live in a world where data is not free. It's not really free to fuse. And so because of all of that data management, all of those hurdles we talked about earlier, there will be a day, like go back to your example of distributed energy resources, right? And somebody trying to do demand response for, a section of Manhattan, right? There will be a day in the future where data will be much more fluid and open, and the conventions by which it gets organized automatically could involve a lot more sources of information being processed simultaneously in a way that people can set up assumptions about where the load is required versus where it's not. If I have primary data to process a particular application, like turn the energy on or turn it off, and if I have a secondary application function that's really just processing in the context of where is the power needed more within this microgrid, to the residuals, where people may have policy decisions or things that they can crank into these systems and say, I'm willing to do this if it only costs X. Yeah. These are layers of processing that occur in that kind of architecture in that future state that afford huge amounts of economies of scale and lots of values in terms of service delivered. But I still need to be able to, like any Lego set, I can't buy 3 different vendors worth of Lego sets and hope that I'm going to get a cool looking castle out of that at the end of the day.
Well, let's go a little bit deeper now. If we've established that is a need for,
I thought I was being deep.
Well, if we take it from a slightly different perspective, if we've established that there is that need to be able to, for a potential implementer of this technology to understand better how they're going to get a return out of it, how does that process actually happen? Is it beholden upon the technology provider to provide that use case to them? Does the customer or the client have to come up with it themselves? Is there a third party that needs to enter into the process, such as a systems integrator or so on, who can help the two sides to come up with that use case, to plan out the ROI and then ultimately monitor if that ROI has been delivered?
Yeah, okay. So that gets to really, I think, the crux of helping industry and society embrace data and analytics, right? It's extremely hard to prove the ROI ahead of time. So first of all, our software is delivered by system integrators, especially engineering firms, et cetera. So they're the ones on the front line with this challenge. But if you think about it, how can you ahead of time prove the ROI on data analytics, which is about learning what the problems are? If you knew them. I have a little joke scenario I go through with it. Let me go through it with you all. And so, I've told you how wonderful the data analytics are and how amazing our software is. It's pretty cool, huh? right? And so you're ready to get going with the project, and you say, well, John, I'd love to, but I got to bring an ROI to my to boss. They're not going to sign off without an ROI. I said, well, I guess maybe I'm unclear. What we're going to do is help you understand where your problems are. We don't know what the problems are, so we can't tell you the ROI. And you say, well, yeah, I get it, but I got to have an ROI. Can you guarantee an ROI? I say, you know what, Owen, I can. I will guarantee an ROI for you if you'll guarantee you fix everything I find. Right. And all of a sudden you go, whoa, wait a minute, I can't do that. And I go, well, why not? Well, I don't know what you're going to find. Exactly. And this is the problem. Now, it doesn't mean it's simple to get through procurement chain, procurement departments. It's a challenge there, right? So back to your first part of your question. How do you deal with it? Well, we deal with it with case studies. I mean, here's an example. It doesn't guarantee it'll do exactly that for you, Owen, but here's an example of how a customer implemented, and here's a specific problem that they solved out of that paid for the whole project, never mind every other piece of value they've gotten and continue to get. So case studies are a part of it. And those are, of course, at our level as a manufacturer, supplier software, and also our partners to show what they've done in different applications, refrigeration, industrial, whatever, right? The other technique we highly recommend is pilot, right? And in fact, we often run into people who there's a whole school of thought about, stop with the pilots, right? And I don't know, maybe we're simple-minded. Do a small pilot. Small meaning cost within your budget. Reasonable amount of data that you can get a hold of, right? Don't, battle the most difficult data, acquisition challenges, and fast to results because, we all like instant gratification or as quick as we can get. And we see people do that. And in 30, 60, 90 days, they've got amazing results. You know what? All of a sudden the whole sales process changes, right? Because now they want to get this implemented because they've seen the value it can deliver, and now they can work their internal processes and communications in the organization because they've got real proof from their own organization. To us, that's the most effective way, actually. It can be slow, but it's clean because they got their results and their value, right? It's, no salesperson's twisting their arm. They are trying to run with it, And especially when it's new to people and data is new and data analytics, you're going to save me money by looking at the data. How you get a magic wand, you got to let people go through that. And we really believe in that even 10 years on.
So in this theme of systemically, right? Think of a vehicle as a wildly tightly coupled system, right? All those systems have to work except for whatever's distracting your kids in the back seat. In other words, you'll kill people, you'll kill yourself, whatever. Think of like a distributed energy management or energy resources context, like demand generation for, large urban areas. Very dispersed, very loosely coupled system, but I can manage it if I've got data and I can use data discovery to do things the way to organize that and, have certain things occur at certain intervals. Think of a building or a factory as kind of equidistant between those 2 points, not tightly coupled, not loosely coupled. Mm-hmm. It's kind of moderately dependently coupled, mm-hmm. Right? That's where I think there are just huge opportunities for, systemic and optimization kinds of impacts. But those are also coincident with what John's saying, which is when you look at the procurement of all of that kind of moderately coupled stuff, it's still mostly bought based on the things, not necessarily how the things behave in a system context and therefore, lend themselves to being optimized. Wouldn't you say, John, if we just limited this for a moment just to the building space, right? It's one of the vertical segments that exists out there in the economy that has the most insane range of behaviors I've ever witnessed, from the stupidest and most Neanderthal and self-inflicted to pretty sophisticated things in places like chilled water plants and, very complex modeling and optimization applied to those kinds of things. But just from your experience, if you were pointing to people and how they should think about this and where in the organizations are people waking up to this, what are you seeing?
Yeah, it's a corporate culture. That's it right there. Numerous examples. Make one example. We have a major multi-site retailer. They've been using our software since 2011. They're driving cost out every year. It's not like, well, I found the faults, I fixed them. There's no more value. There's always issues, faults, opportunities. They're the ones who started comparing facility designs, service calls per vendor, and then another one that I've met with for 7 years. They can't easily even put their hands on their energy data per site, right? What is the difference? The buildings are the same. They sell the same goods. The difference is corporate culture. And that's, something that is only going to evolve or not. We've learned that you can't overcome that really. We've never found a way to overcome that with the sales process, right? People, how do they look at their organization, their operations, and what's their attitude about embracing technology, doing a pilot, looking to understand data? It comes down to corporate culture. It's not building type. We often have people, okay, so where's your software? What type of building, what type of facility, right? You get everything from bank branches to the biggest skyscrapers in the world. What's the commonality? They all have equipment systems that with sensors and loads, and they consume energy resources. And the other commonality is corporate culture, right?
This pretending future of haves and have-nots, those that get it and those that don't. To some extent, over time, I think this will actually divide a lot of the financial performance of the world up in the business context.
One of the, I would say, potentially encouraging that we're seeing, I was just reading an article this morning again on it, is that, the concept of a word cloud, how often a term appears, right? Well, I read this investment letter and they analyze annual reports. And they say, here's the hot 3 words this year and this year and this year. And one of the ones that's coming out is ESG, right? Environmental, social governance, of which efficiency is part of it. There's, the other parts are important. That's the environmental side. And they're saying not only is it appearing more, I just read that a major corporation was adding that into their bonus structure for their C-level execs. There are now goals around that. So if you're going to try to improve the E of ESG, you're going to need data, right?
Right.
And so if it comes top down, then there's going to be hopefully pressure on the organization and a willingness to try to embrace, adopt, pilot, explore, learn about these things. But it's not universal. And I agree. It's bifurcating, and there's organizations living in the dark ages trying to figure out why they continue to do worse and worse and worse, right? But they just not ready to step up. And I mean, that's right, the capital destruction cycle, I guess. We're seeing it play out around data.
I was trying to think about economic shocks. Could we look to perhaps the 2 issues that really kind of dominated our winter and maybe even the last year were COVID and the deep freeze in Texas?
Between climate-constrained resources and then these infrastructure screw-ups, that you have a rapidly converging awareness of, the brittleness, the rigidity of everything from procurement to how the system operates, right?
We've seen examples where COVID has increased the awareness of organizations. They need to remotely manage their facilities more effectively, and of course, that leads to data. I think there is an increased awareness.
Yeah.
But it hasn't materialized in policy and behavior enough yet. You see some individual cases that prove the point, but it's not across the board for a variety of reasons: complexity, economics, understanding. Again, a lot of times the people who own and operate these facilities, they don't understand these issues. So, how can they make a decision, and are they prepared to hire a new type of consultant, right? A data strategy consultant?
Yeah.
Whoa. A what?
To some extent, I just think this is like a new cultural orientation that will only be ultimately driven by constrained resources. People will eventually have to pay attention to how all this fits together. So, context is king, behavior rules everything, and it's hard to get people to organize to do the right thing and all point in the right direction, which leads me to ecosystem, because all this is a bunch of relationships between and among players who build things, people who service things, design systems, and so forth. Like, John, what's been the progress with Haystack, the enabler of the whole data vocabulary that exists in smart buildings?
Yeah. So let's just spend one quick minute about Haystack. Project Haystack is an initiative, the open source initiative. We were one of the founders 10 years ago. It's 10 years old this month. Okay. And it's a metadata standard, a tagging standard to mark up data that comes out of machine sensors, IoT devices in a uniform way so that it can easily be utilized by software applications, right? It gives us that, holy grail of uniform data. If you tag your data following the Haystack methodology with the Haystack tags and this Haystack ontology, then any data, no matter what device it came from, can be used and correlated and analyzed in the context of all the other data. So that's what it is. And it's an open source initiative. And so, it's there to help us all in industry solve this huge problem, which is that the data coming out of equipment systems has limited, none, or totally proprietary semantic descriptors. Yeah. Right. So there's a huge manual heavy lift when I want to do anything with the data from a equipment system other than work with it from the manufacturer's point of view with their app. Right? And it turns out that that's oftentimes the biggest cost in the system integrator's line item to do a project around data. It's the data munging, data mapping, data wrangling, it's referred. So Project Haystack gives a methodology to solve that. And ideally, we would see that extend further and further down so that devices came with self-describing data. Plug and play printers, anybody? I've been around long enough when setting up a printer on a computer was a major deal, right? Now, every once in a while you have a problem, but you buy it, you connect it, and it works. Why? Plug and play. Well, that's what Haystack's for, is the plug and play of data from devices, equipment systems, et cetera. So interestingly enough, it's widely used, but we have found, unfortunately, a hesitancy by the major equipment suppliers to commit to using, an open source tagging methodology, or to admit they're doing it, which is even weirder, right? Right. They're using it. But they won't advertise or talk about it or whatever. Don't see enough of the manufacturers building it into their equipment. So that means the system integrator will be faced with the mapping of data if they want higher level applications to be able to work with it. Right. But if they do it there, at the control system level, at the network gateway level, then, from that level up, the ability to work with the data is far easier and the costs of interoperable data dramatically reduced or eliminated, but there's still that step. And that is something that's going to have to change to get to this grand vision of truly, interoperable data, because this is a cost point and an impediment to getting there that, those owners who have a question about the value of the project, they're the ones who have to pay for that. And it's completely non-productive work, but it's still being approached hesitantly by the equipment manufacturers, and that is holding back the IoT. It's holding back unknown data related applications that you won't, like we've talked about, discovering insights. You can't do that if you can't get the data. And if you don't know what you're going to find, you can't justify the project, and you end up with this vicious cycle that continues to hold industry back.
Actually, let's go back to basics for 2 seconds. We did this massive analysis a couple of years ago on data and analytics projects, and inclusive of things that included modeling for machine learning and that kind of thing. And basically, someplace between 65 and 70% of the cost of the project was just organizing the data in order to make it useful.
Exactly. Because that 60 to 70%, that's a huge barrier in cost, but also in this psychological component, right? You're telling people, this data analytics, part of the problem, it's kind of amorphous, right? If I'm going to sell you, the analogy I make, I'll sell you a LED light bulb. If you screw it in, you will save this much money. No, Glenn, I'm going to get your data, and with magic intellectual knowledge.
This is like, I used to use the analogy. This is like why Henry Ford built River Rouge. I'll build my own metal and my own rubber and my own glass in order to build an automobile.
Yeah.
That's kind of where the state of data is today.
Yeah, it is. And it's a barrier both financially and psychologically, because think about this process. That's 67% that took time, that took involvement of people, that probably frustrated whoever approved the project. Why don't I see anything yet? And this is not a,
I would never want to do that again.
Yeah, right. I don't want to do that again. Even when we save some money, So anyways, these are all of the complex issues around working with data, but they're not going away and they are getting solved. One thing I say is, I've been through the industry for 35 plus years, as you have, I'm pretty comfortable that, Glenn, we're not going to sit down in 5 years over a beer and go, remember when data was the big thing? Oh, that fad's over with. I'm pretty safe on saying that's not going to happen.
Yeah, probably not.
Thanks to John and Glenn for being such great guests today. Don't forget to check out harborresearch.com for more insights on smart systems. This podcast was edited and produced by Christy Zook and moderated by Owen Jennings.
Harbor Research is a growth strategy consulting and venture development firm with over 30 years of experience working with leading manufacturers, service providers, and technology developers to discover, design, and develop smart systems and Internet of Things growth opportunities. Visit harborresearch.com to learn more or follow us wherever you get your podcasts.